Welcome to another episode in the History of Science series. Today we explore one of the most famous and puzzling thought experiments ever proposed, Zeno's paradox of Achilles and the tortoise. At first glance, this seems like a simple story about a foot race, but Zeno used it to raise a profound challenge about motion itself. If space and time can be divided endlessly, then motion may not be as straightforward as it appears. This paradox forces us to think carefully about infinity, logic, and physical reality. Zeno of Elea lived in ancient Greece during the 5th century BCE. He was a philosopher and a devoted student of Parmenides. Parmenides argued that change and motion were illusions, and that reality was unchanging. Zeno defended this radical idea by constructing logical paradoxes designed to expose contradictions in everyday thinking. His paradoxes were not jokes or riddles. They were serious philosophical arguments meant to challenge deeply held assumptions. Zeno asks us to imagine a race between Achilles, the fastest runner in Greek mythology, and a slow-moving tortoise. To make the race fair, the tortoise is given a head start. Achilles is clearly faster, so common sense tells us he will easily win. Zeno agrees, but only if we stop thinking too carefully. Once we examine the race step by step, a surprising problem appears. To catch the tortoise, Achilles must first reach the point where the tortoise began. However, by the time Achilles reaches that point, the tortoise has already moved ahead slightly. Achilles has made progress, but the tortoise is still not caught. This creates a new distance that Achilles must now cover before he can reach the tortoise again. Each time Achilles reaches the tortoise's previous position, the tortoise has moved forward again. The remaining distance becomes smaller and smaller, but it never completely disappears. Zeno argues that Achilles must complete an endless sequence of steps, each one bringing him closer, but never allowing him to finally catch the tortoise. Zeno concludes that Achilles must perform an infinite number of tasks in order to catch the tortoise. If completing an infinite number of steps is impossible, then motion itself must be impossible. Achilles never reaches the final step because there is always another distance to cover. This conclusion directly contradicts everyday experience, making the paradox deeply unsettling. This paradox created a serious problem for ancient thinkers. Logic seemed to suggest that motion could not occur, yet experience clearly showed that it does. For philosophers who deeply trusted logical reasoning, this contradiction demanded an explanation. Zeno's paradox revealed that common ideas about space, time, and motion were incomplete. The resolution to Zeno's paradox did not come until much later, with the development of new mathematical ideas. Mathematicians eventually showed that an infinite number of ever smaller distances can add up to a finite total. Achilles completes infinitely many steps, but in a finite amount of time. This insight became central to the concepts of limits and infinite series, which later formed the foundation of calculus. Zeno's paradoxes played an important role in the development of mathematics and physics. They forced thinkers to confront the nature of infinity and motion in a precise way. Even today, these paradoxes are discussed in philosophy, mathematics, and modern physics, especially in conversations about continuity and time. Zeno did not prove that motion is impossible. Instead, he revealed that understanding motion requires careful reasoning and new tools. His paradox reminds us that logic can challenge our intuitions, but it can also sharpen them. By questioning something as familiar as running, Zeno helped shape the future of science and mathematics. Thank you for watching.